Hi guys, welcome to Coding World. So in this tutorial we are going to discuss dynamic programming. Okay, so let us start with dynamic programming. So let me tell you what is dynamic programming. Okay, see, dynamic programming is not a programming language. Okay, most of us thought that it is a new programming language. Okay, like C++, C, Java, Python, but it is not a programming language. Okay, it is a concept, or you can say rather than concept, is a technique used to solve coding problems. ओके तो किस टाइप के कोडिंग प्रॉब्लम्स हम लोग यहाँ पे सॉल्व करेंगे? हम लोग यहाँ पे उस टाइप के कोडिंग प्रॉब्लम सॉल्व करेंगे जिसमें हम लोग देखेंगे कि टाइम कॉम्प्लेक्सिटी एक्सपोनेंशियल आ रहा है. व्हाट डू यू मीन बाय एक्सपोनेंशियल? वेयर वी कैन सी दैट वेयर द टाइम कॉम्प्लेक्सिटी इज बिग ऑफ 2 की पावर n, or you can say big of 2 power k, where k is any integer, या even or odd multiples of 2, 3, any number. What I'm trying to say is that where there is time complexity of big of n, so in order to optimize the solution of the particular coding problems we use dynamic programming. Okay, so now let us discuss what is the approach for dynamic programming, how we can know that the particular problem is going to be solvable by dynamic programming. Okay, so let me tell you, dynamic programming, this technique was founded by Bellman. This technique, basically the way to solve the problem by dynamic programming approach is given by Bellman. Basically in graph data structure and in advanced concepts of graph data structure, we'll discuss about Bellman-Ford algorithm. Okay, and it's lots of applications. This scientist Bellman-Ford in 1950s around, he has given this technique, dynamic programming, to solve the coding problems. Okay, also we'll discuss Bellman-Ford algorithm that is given by Bellman scientist, that is basically based on dynamic programming approach. We will also we have already discussed this technique in Bellman-Ford algorithm. Basically we have in graph and in advanced graph sections. Now in this particular tutorial we are going to discuss dynamic programming. Okay, so let me tell you one thing, that suppose in the very first day of coding, what we have learned how to calculate Fibonacci number. Okay, let me tell you what is Fibonacci number. Okay, so Fibonacci number is nothing but it is 0 if n is 0. Okay, it is basically, these are 3 cases. This can यहाँ पे 3 केस हो सकता है. The first case is 0 when n is 0, 1 when n is 1, and fib of, you can say, n minus 1 plus fib of n minus 2 if n is greater than equal to 2. Say whenever there is n is 0, we are going to say that is Fibonacci of n at 0 is 0 and n at 1 is 1, and for n greater than 2 it is fib of n minus 1 plus fib of n minus 2. So these are 3 basically approach. So if you combine these 2 logic, we can say here we can return n if n is less than equal to 1. So either you can write this logic or you can write this logic. Okay, so this is a recursive function. Okay, so why I'm saying this is recursive function? Because suppose this is the original function, then I'm again going to call this function for n greater than 2, see, fib of n minus 1, and I'm passing the parameter as, suppose here is the original parameter as n, then I'm passing here it as n minus 1. And what are the base cases of this recursive function? These are the 2 base cases, n is 0 and n is 1. Then I'm going to return 0 and 1 respectively. Okay, otherwise it is going to call recursively this. So one thing it is sure, that this this function going to take memory in stack as big O of n, you can say. And what is the time complexity of this function? We'll discuss about this time complexity in a little in a little while later. Okay, let me tell you one thing, that suppose if I'm going to draw the recursion tree for this function, then how it is going to be drawn. Okay, and one thing, okay, let me first draw its recursion tree. How it is going. Suppose I'm giving n as parameter, then I'm going to call for 2 parameters, that is n minus 1 and n minus 2. Okay, how I'm saying it, suppose if my n is not 1 and not 0, then definitely I'm going to call this two less parameters passing, basically decreasing the value of n, and again I'm going to call this function. Suppose if n minus 1 is not 0 or 1, then again it is going to call for n minus 2 and n minus 3. Similarly, see, it is very important to visualize here. Okay, so try to visualize it. Suppose if n minus 2 is not 0 or 1, then again it is going to call for n minus 3 and n minus 4. Okay, suppose again n minus 2 is not 0, then again it is going to call for n minus 3 and n minus 4. Similarly, so and so forth. What is the last condition? We can say last it will stop when n is 0 or n is either 0 or 1. So what we can see that, suppose how we are computing, suppose first we have suppose we have calculated the value of n minus 1. Okay, and suppose we have also calculated the value of n minus 2 and n minus 3. Okay, these functions has already returned the whatever the value they have computed. Suppose, but you can see here that once I'm calculating n minus 2 here, but again I'm calculating n minus 2 here. I'm computing n minus 2 here one time here and another time here. So what we can say that you can see here that we are computing same function again and again. So see here I'm calculating n minus 3, here I'm also calculating n minus 3, here I'm calculating n minus 4, here also I'm calculating n minus 4, here n minus 3 calculating, here also n minus 3, here also n minus 3. So you can say that a similar function is going to is going to be computing again and again. So this type of structure is known as optimal structure, optimal substructure, optimal substructure. Okay, so this is the suppose whenever we see that there is optimal substructure, this basically there are two ways to see whether a problem is solvable by dynamic programming or not. First one is we have to find out where there is in the problem it is optimal substructure is there or not. If in the problem there is optimal substructure, then definitely we can say that that problem can be solvable by dynamic programming. But it is solvable by dynamic programming, it is not yet clear. For to clear all these things, we have to check for another condition. This is the first condition, this is the first condition. Okay, another condition is we have to look for overlapping sub problem. See, what do you mean by overlapping sub problem? Overlapping sub problem means, suppose here I am calculating n minus 2, here also I am calculating n minus 2. So same problem, this basically, suppose this is the problem, so these are sub problems and these are overlapping. Basically it is the same sub problem is occurring many times. So this is known as overlapping sub problems. If I am going to calculate computing the same sub problems again and again, then definitely that problem can be solvable by dynamic programming. And also one thing you should remember, that there must be optimal substructure in order to calculate the given problem by dynamic programming. If you are going to code in dynamic programming, then these two conditions must be satisfied. Okay, so suppose what we can do now, you can see here as suppose if I am going to maintain an array of size n plus 1, okay, this is the size, basically this many number of elements this array will contain. Okay, if I am going to maintain an array of this much size, and what I will do nothing. Suppose the first time I will calculate n minus 2, I will put it in this array. This is done. Okay, now suppose if I am calculating again, suppose when n minus 1 is going to compute its function, it is going to call n minus 2. But see, I have already calculated n minus 2, so I will simply check in this array where I have calculated n minus 2. Okay, suppose what I am trying to say is, in this array function, basically this many number of elements with the n plus 1 number of elements are in this array. Okay, so I am going to check the place of n minus 2th position, and I will check what is the value at n minus 2, and I will simply return this to n minus 1. Definitely then I do not have to call n minus 2, or I do not have to compute n minus 2 again and again. So definitely so if I'm going to maintain this array, so what is the benefit of maintaining this array? Simply we can say the benefit of maintaining this array is we are not going to compute the same function again and again, so that one function can be computed only once at a time, and hence the time complexity now reduces to big O of n. See, okay, now see, in this, in this recursion tree, suppose if I'm not doing it by dynamic programming, then what I can say, the time complexity is big O of 2 raised to the power of n, which is exponential time complexity. In case of Fibonacci number, if I'm not going to maintain this array, if I'm not going to do this problem with the help of dynamic programming, then definitely we can say that the time complexity of this problem is big O of 2k power n. And suppose if I'm going to do this problem by dynamic programming, then definitely I can say there is optimal substructure in this problem, overlapping subproblem in this coding problem, then definitely I have to maintain an array, and the one function which is occurring one at a time, I will keep its value, whatever the value this function will return, I will maintain this in array, and whenever the same function is going to compute, I will not compute, I will just simply check if in array it is already computed or not. If it is computed, then I will simply return to its parent function. So that now the time complexity is reduces to big O of n. So this is the time complexity. Now what about space complexity? Definitely it is a recursive function, so definitely it is going to take a big O of n solution. So what is the recurrence relation of this function? The recurrence relation of this function is tn is equals to tn minus 1 plus tn minus 2 whenever n is greater than 1. See, 1 is not included here, and it is 1, it is basically n if n is less than equal to 1. Okay, so this is now we have already discussed in asymptotic analysis that the time complexity of this type of function is definitely big O of 2k power n. Okay, and hence this is the recursion tree. Okay, so we'll also discuss more about this, how we can now I will show you how we can solve this Fibonacci number using dynamic programming.